We just looked at how the functions of a monolithic application can be broken down into microservices. Our hypothetical video processing application could be broken down into a web service and a video processing service. Specific instances would run the web service and other instances would run the video processing service. In other words, each service is tightly coupled to a particular instance. But what if, for example, the web service crashes on a particular instance, perhaps due to a bug? That's going to impact availability. So, what can we do about this? Well, years ago, software developers took the concept of loose coupling to an extreme by decoupling individual services from the instances they run on. And here's what they did. Instead of deploying one service on one instance by just putting a binary executable on the instance, they deployed multiple services in tiny little virtual machines called containers. A container has memory, a file system, a network stack. You can start it, stop it, and so on. Now, some people say containers aren't truly virtual machines, but a container looks and acts like a virtual machine. Here's the point. On a single instance, we could have multiple copies of the web service running in separate, isolated containers, and they won't interfere with each other. If the web service running in one container crashes, it will have a minimal impact on availability because there will still be many other copies of the web service running on that instance. One of the most popular container platforms is Docker. And the way Docker works is pretty simple. You build an image that contains a Linux file system and all the files your microservice needs to run. You deploy that image to an instance, you spawn a container from it, and your service runs inside of that container. This is very similar to what you do when launching an EC2 instance. To use some analogies, a Docker image is analogous to an AMI, an Amazon Machine image, and a Docker container is analogous to an EC2 instance. Containers make deployments and updates a lot easier. You build the Docker image once, deploy that image to your instances, launch a container from the image on each instance, and you're done. Containers can help you improve availability. Under a monolithic architecture, if your service crashes on an instance due to a bug, then that service is down on that instance until something or someone restarts it. You've lost the additional availability that instance was giving you. But using containers, you can run the service in multiple containers on a single instance. If the service crashes in one container, again perhaps due to a bug, that container stops, but the other containers keep on running. In a way, it's like getting multiple instances for the price of one. The Amazon Elastic Container Service, or ECS, makes it really easy to use containers. In ECS, you place your instances in a cluster according to service. So you'd have one cluster with your EC2 instances running the web service and another cluster with the instances running the video processing service. AWS can store your Docker images in an Elastic Container Registry or ECR repository. To launch your containers, you create a task definition which defines everything the container needs to run. The Docker image, CPU and memory allocations, network configuration, storage, and so on. Pretty much the same sort of things you define when creating a virtual machine. ECS uses your task definition to spawn containers on the EC2 instances in your ECS clusters. ECS can even configure your Elastic Load Balancer to send traffic to your containers. This way, if a container goes down or the service running on it crashes, users will not get proxied to that failed container. Recall earlier that we calculated an application availability of 99.92%. If we were to use ECS and its availability is 99.99%, how would that change our total application availability? ECS would become a hard dependency, so we'd multiply the two numbers together and get 99.91%. Now you might be thinking, wait a minute, what's the point of using ECS if it decreases our availability? Well, remember that our availability calculations are based on the AWS Service Level Agreements, the SLAs, but actual availability can be impacted by things outside of Amazon's control. For example, if you're running buggy application code that causes a memory leak, ECS can help you avoid an outage by limiting the amount of memory allocated to each container. You always want to be thinking about how your design itself can impact availability. Another example, the web service may have a vulnerability that an attacker can use to get shell access to the instance. Well, if that service is running in a container, you have a level of isolation between the container and the host operating system, as well as between the compromised container and other containers. Obviously, an attacker messing around in your system can definitely hurt availability.